All right, hello everyone. Welcome to week three. Uh, is it week three? No, week four. Week four of our CCDC bootcamp. This week we're going to be covering Linux fundamentals and security, to be more specific. So yeah, this is where we in week four. Pretty much a little bit more than halfway through. Next week we have Windows, and then last week will be common services. But yeah, so just going over introductions again. My name's Adam. IST sysadmin intern at Esri. Um, I'm also your CCDC co-captain and Linux lead this year. Last year, I was our CCDC Linux database lead. Um, I have my bachelor's in CS and a minor in cybersecurity. Graduated here last spring. That's a picture right there. I was carrying the banner. Or you think so? Yeah, this aura. I look kind of lame. But this fall, I'll be starting the Master's of Information Security. I have my Sec Plus and Network Plus, and I'm really into this game called Slay the Spire.
Oh, hi everyone. My name is Anson. You could That's my Discord too, and currently I'm a cybersecurity intern at Varda. That's all I do. And last year I was a CCDC Linux lead, and during that summer too, I also worked at Taco Bell IT. And then before that, I did nationals for NCE Cyber Games. Technically, I'm on my last semester of school, and I'll graduate. I'm basically done, and then I just like monkeys, as you can see from the two monkeys right there.
Hi guys, I'm Nat. Currently, I'm a cyber defense and engineering consulting intern. I'm also your CCDC co-captain. I've been doing networking for the past 2 years. I've been there. I'm fourth year CS, and I really, really love frogs, as you can tell.
Did you crochet those? All of
No,
those?
I only crocheted the one with the overalls. Everything else was gifted.
Oh.
That lives on top of my PC.
All right, so today we're going to be covering Linux fundamentals, Linux administration, Linux security, and then networking and firewall. I know last week we covered networking, but we wanted to go a little bit more in depth this week, and do a little bit more hands-on activities. So first we'll be starting with Linux fundamentals. I'm gonna first talk about what is Linux. Like a lot of people don't understand that Linux is not an operating system. There's a lot of different flavors of Linux, like Debian, Ubuntu, CentOS, Alma Linux, and all that kind of stuff. So um, it's important to understand that these are flavors of Linux. They're not technically different operating systems because they all share and they all have in common that they use the Linux kernel. And um, this is built on Unix, so it's Unix-like. But the great thing about Linux is that it's free and open source. So, and this is kind of like what the stack is. There's like hardware, and the kernel builds on the hardware to kind of manage it. And then you have your shell, and then the applications on top. A lot of more basic versions of Linux or flavors don't really use that many applications. They have a lot of services, and some have GUI and some have just a terminal. So let's talk about terminals. So a lot of people are probably familiar with this. When you did the networking homework last week, you probably used the terminal on the Debian machine. But there's like two versions. There's like the desktop versions and like the server versions. The bottom right one is common with Ubuntu. It's a headless kind of server that doesn't have a GUI. And it's just a command line. And then there's a desktop version that's better for like user experience because there is GUI and you have like your applications and you can do a lot of things through just the GUI. The Debian is a great example of that from the homework from last week. Now I want to go into the Linux file system. This is a very important part of the Linux systems. It's split into a lot of different directories, but at the base we have the root directory, which is just represented by a forward slash. And under that, we have a lot of different directories. I'm not going to go into every single one of these because not all of them are super critical. Um, but some of the important ones are etc, uh, home, root, user, uh, temp sometimes, and opt. So Etsy is the main directory for where your configuration files are for services. And this is really important in a competition where everything depends on your services. So this is where you want to look for to make sure your services are secure and configured correctly. Next, I wanted to talk about home. This is basically the home directory of where all of your users kind of belong. So any users that you create will have a home directory under this directory. Next is roots. This is different from home because this is the home directory of the root user. I'm saying root a lot, but there's a difference between root directory and the root user. Now, on a lot of systems, I'm sure you guys are familiar with like the root user and needing like additional privileges to run certain commands. That's the root user, right? You need the root user permission to run a lot of different things, right? And then there's the root directory. That's different because it refers to the base of the file system. And then we have user. This is kind of where all the binaries are held, and binaries are kind of like, for lack of a better word, like your commands. So binaries for all the commands that you kind of use in the command line, like ls, CP, MV, and all that kind of stuff that we'll be talking about a little bit more about later are kind of held here. And then you have temp. This is where all your temporary files are. I think Red Team sometimes puts their kind of stuff into temp folder.
That's like their main way.
That's their main way, kind of. And then opt is for installed applications and like services. So whenever you have like Docker or Kubernetes installed, usually you might want to look for it here. So yeah, traversing the file system. Now that we kind of know what the file system is, we want to know how to like move around it. So as I mentioned earlier, we kind of start with the root directory, which is a forward slash, and this is of course the base of the file system. So when you have what's called an absolute path, this is basically describing the path of where the file is from the root. So starting with the root directory. And then in the opposite hand, we have the relative path, which basically starts with where you currently are, and that's different from the absolute path. Here we have like, we say use PWD, which stands for print working directory, and that tells you where you currently are in the file system. And then we have different ways of referring to where you are or where you were. So the current directory, you use the dot or a period, and this represents like where you currently are now. And the previous directory, you can refer to that using 2 dots. And then in the bottom, we have some examples of how to traverse the file system. So the top left command, cd/home/user/desktop. So slash, of course, you always start, this is an absolute path. You have slash and then home. So that was one of the directories we talked about. And then /user. So that's another directory under home. And that is basically saying this is the user called user home directory. And then under that, we have another directory called desktop. This is default. This is typically like how the file system is by default. On the top right, we have cd ... That just means go to the previous directory because, again, we mentioned you can refer to the previous directory using ... And then we have another example of seeding to another pretty important file location /var/www/html. This is a lot of where the web stuff is located. And then you have cd tilde /downloads. Tilde is an important reference tool. It refers to your current user, like the user you're logged in as, their home directory. So if you were the user called user, like the networking homework, using the tilde would represent /home/user. It's just a shorter way of referencing their home directory. But of course, if you were the root user, that would lead you to /root because that is the root user's home directory, and that's different. And then the bottom is just like different files or names to list files. So the left side is an absolute path, the bottom left is an absolute path, and the bottom right is a relative path. And I wanted to go over again like what the difference is between the roots, because there's root, like the root user, and there's the slash roots, which is the root user's home directory, and then there's just the regular slash, or also called roots. So it's like kind of a, I guess, a tongue twister because there's a lot of different, there's a lot of roots. So yeah, the root user has a UID of 0. This is like your admin user on a Windows machine. And it has 0 because it's like the base of everything. And you have the root directory, which is just a forward slash, and this is the start of the file system, as I mentioned before. And then your root user's home directory slash root, and that's important to know the difference. So now we're going to go into like commands. Your command line, you always have pretty similar syntax with commands. It's usually the command that you want to use, the options that you want to include, and the arguments either for those options or for the command itself. Some examples are ls, cd, and IP tables. Those are pretty commonly used in a Linux VM, but I wanted to do a little bit more hands-on today, so wait, I just realized we didn't go over the homework. But yeah, we have, I believe, the Linux VM here. We gotta stop share on there, right? And share on this side. Yeah. Zoom, can you guys see this? I'm sharing Proxmox. Yeah, cool. So I'm gonna log in here. Huh? 10 FPS on the Zoom, that's crazy. That is terrible. But I'll go ahead and open the terminal. Oh, we're not showing it on the. That's great. Just move that to here. Oh, they had the 10 feet. Yeah, there we go. It's a little small. I can zoom in on the terminal. Oh. No command. Oh my God. There's control menus. Oh yeah. You're gonna move this one down now. Yeah. Yeah. There. All right. We got a little bigger. So one of the common commands is using ls. This stands for list. And that just lists the current contents of where you are right now. Yeah, and just like we mentioned before, these are like here by default with the user. They have like desktop downloads, kind of similar to what you would see for a user on Windows. And there's different arguments for this command. Like if you do ls.l or tag l, that will list like the permissions of all the files listed here. We have the lsla, which A will show like hidden files within the current directory. So here we have a couple hidden files, and hidden files are just files that start with a dot. And normally when you do ls, it won't show the hidden files, but when you include the A and the option there, it'll include a lot more, as we can see here. But yeah, that's the kind of like the basic gist of how commands work. Yeah, we gotta stop sharing on this side and then reshare the presentation. Yeah. Perfect. Nice. So yeah, just as I kind of just went over, listing files, use ls, and there's common options that we use, tag L and tag A. I actually forgot to mention that when we say tac, that means dash. A lot of people get this confused. Like, what the heck does this guy mean by tac? Tac means dash. We kind of just find it to be a little bit faster to say. Um, and also when we're creating files, there's a couple commands we can use. A common one is touch. So if you, this guy just touched me. Following your direction. So if you do touch and then the name of a file, it'll create a file with that name. And then if you use a text editor such as Nano, Vim, or Vi with your file name as the argument, you can also create a file that way if it doesn't exist already. Should we go over that?
What do you want to describe?
Let's see what we have here. Yeah. So next we're going to talk about commands that you can find with a right click. Like when you right click on Windows, you can like a right click a file, you'll see like copy, move, deletes, or stuff like that. And we have something very similar to that on Linux. So we have CP for copy, MV for move, cat for listing the contents of a file, RM for removing a file, and then mkdir or make directory to create like a folder or directory. Do you want to go over these? Yeah.
Up here. Right here.
We share multiple. Does that? Yeah. I don't know.
Yeah. Oh,
Yeah. So yeah, as I mentioned, we have like you can create files using touch. You can just say create a file called touch hello. So there's a file called hello. If we do ls, the file we just created is there. And then we can copy it. So the arguments you need for this command are like the name of the target file and then where you want to copy it to. If you just do a file name, it'll copy it to your current location, but you can specify a location to where to copy it to as well. But we can just do like hello1. And if we ls again, your two files are there too. And then if you move this, we can move hello into downloads, I guess. So first we'll start by referencing the current directory and then put a slash to move to the next or indicate that you want to name a directory, and then you can put downloads. I can't spell. But if we do that, if we ls again, we'll see that the old hello file is no longer there. But if we ls that directory, yeah, you can also do like that, right? And that'll do the same thing. But I guess it makes more sense if you do dot. Yeah. So kind of know where you are. You can also do the pwd command to print out your current directory to show where you are. And by default, you'll start in your current user's home directory, which is represented by the tilde here. And then you can switch using, of course, the CD. So if we go to downloads and ls there, the hello file is there. Yeah, we can remove it as well. So using the remove rm command, we can target that file. If we ls again, it's not there. We go back a directory. It's not there either because we removed it. We can also make directories. So if we do mkdir like test or something, this will create a directory in the current location. So if I do that, we have a directory called test, and it's in blue to indicate that it's a directory. Also, if you do lsla, we're going to go into this a little bit later, but looking at the permissions on the left side, this character D here indicates that it's a directory as well. Yeah, I also want to talk about the text editors we mentioned. There's Nano, Vi, and Vim. We don't really use Vi anymore because an older version of Vim. So for beginners, Nano might be kind of your more beginner-friendly text editor. So if we do Nano hi or something like that, we go into a text editor, and now we're editing a new file called hi. Um, we could just type anything in here. And then to save, you do Control X and type Y and press enter. So now by ls again, we'll see that the file I created is there using the text editor. And like I mentioned before, you can use cat to list the contents. So you cat hi, and then it'll list the contents of that file, and that's what I typed in earlier. A more advanced text editor is Vim. This is what we recommend for people that want to get more into Linux. It uses a lot of shortcuts to make things faster and more convenient compared to Nano. Um, so if I Vim to the same file we had earlier, it'll go into the same file and show the text we typed in earlier. But a common command you might use in Vim is just pressing D twice, and that will delete the line that you're currently at. And then to save, you just do W colon and then WQ to save. And now if I cat the same file, there's no contents in it because I just deleted the line. But yeah, I definitely recommend learning Vim. It's very helpful and much faster than using Nano. Okay, we can go back to the slides. Stop share on this. Yeah, and then share the presentation. Oh, yeah, there's a flag here. There's flags here listed. So tag F means force. Usually when you remove a file, it'll ask you, are you sure? And if you do tag F, that will basically ignore that prompt and just delete it without asking. This can be dangerous, so just be careful what you delete. And then when you do tag R, that means recursive, so it removes anything in the directories that you like target. So something that's very dangerous, and I don't recommend any of you do it, is remove tag RF space slash. And that basically, like the forward slash is your root directory. So if you delete everything in the root directory recursively, you're deleting your entire file system. So that definitely not recommended unless you're working on a VM and want to have fun. And then for make directory, we have tag P or parent. I think this just creates any parent directory that you name along with the directory here. So we have path slash directory name. If you had multiple directories listed before this that don't exist already, it'll go ahead and create those for you as well. So now we're going to go more into Linux administration. Some common things that we look out for during competitions. One thing is environment variables. These are like variables set in your terminal that can be used and called at any time or changed as well. And you might have like scripts or files that kind of depend on these. So it's important to look out for certain ones. A common one is your path environment variable. This basically tells or specifies what command you want to use and where to look for it. And the order here is extremely important. So it goes from left to right, separating the locations by colons. So when you type any command, it'll look here, your user local sbin. And then if it can't find it there, you do user local bin, and it just goes on like that until it finds it or doesn't. And to list environment variables, you just use the env command or env, and it'll list all of the currently set environment variables. There's also aliases. These are basically ways to create your own commands to an extent. So if you set an alias for the text here, when you use the same text in the command line, it'll reference that. So here, we use the alias command to list all currently set aliases. These are the bottom ones here. The bottom four here are pretty common. Some Linux distros set them by default. Some might not. But at the bottom here, I have an example of we're creating an alias called CCDC, and this is the command it's kind of executing whenever you call that alias. So echo is a command that just says like repeat or kind of like say it. So we see echo CCDC spelled differently. And then you call that alias, it'll echo the same text that we have here. Now I'm going to go into like strings and like, I guess, command line tools. I talked about this earlier, using Nano to edit files. This is installed by default on most distros. It's a very basic text editor. It doesn't have that many tools to it. Yeah, as I mentioned earlier, use Control plus X to exit, and then press Y to save as the same file name. And here's an example in the bottom right. This is great for beginners, but can slow you down when you're trying to like go through something really fast. Next, we have Vim. This is like the GOAT of file editors. I definitely recommend trying to learn this. It basically lets you run commands in the editor, so it becomes a lot faster to like traverse the file. And then something to know is that it might not be installed by default, but it can be installed pretty quickly. I think it's systemctl, or not systemctl, apt install vim, right?
Yeah, depending on the package.
Yeah, it depends on the package manager, but we'll cover that a little bit later. It's extremely customizable, and then it has like 5 different modes. Can't really name them off the top of my head. It's like inserts. There's replace as well. And there's your view, which is like the default. And there's a few others. Can't remember. I think there's append as well. Yeah. But to learn Vim, I definitely recommend using this thing called Vim Tutor. It's something that's built into the command line. I'm pretty sure if you just type Vim Tutor in your command line, or is it Vim Tutor, like edit Vim Tutor? I tried using Vim Tutor and then I was like, dude, this thing is too long. But I definitely recommend going through it, at least some of it. Yeah.
And I really want to reiterate what they said before. You should learn Vim beforehand because a lot of containerized environments used a version of Vim or Vi. So if you're going to learn a text editor, might as well learn this one and not use so much time on Nano, in my opinion.
I mean, Nano only takes like 2 minutes to learn. Yeah. Vim has a lot more to it. Yeah. Next I want to talk about this command line tool called sed. This basically lets you script out file changes. And something that you might commonly do is like search for a pattern inside of a file and replace it with something else. And that's bottom left point here is how you would do that. You do sed tag I and then single quote s / and then the pattern that you want to find and then / and then what you want to replace it with. And that replaces every single instance of it. And then after that, you would specify the file that you want to look into. It can also match regular expressions, so that's something to note when you want to script something. In the bottom, we have an example of that. So if you cat this file called file, it has this text. The quick brown fox jumps over the lazy dog. And then if you script it using sed to find the pattern fox and replace it with dog, and then cat it again, we can see that fox was replaced with dog. Something to note here is that this person used a semicolon to run multiple commands at this, like one after another. So first they do sed and then semicolon, and then they cat the file. So they do this action first and then cat the file right after. And that's why we're seeing the contents again. And then they replace dog with wolf, does the same thing. And then replace the with a. And that replaces this the with a and then the one at the beginning as well.
I think a really important distinction between the second and third times you're using sed is the /g at the end. And I'm pretty sure that G means global, so you're going to replace everything in the file. Otherwise, without the G, you're just going to replace the first instance of the pattern.
Yeah, so if you look in the example, like this one, the second command here doesn't have the G at the end, and it replaces fox with dog, but there's only one instance of fox, so we can't really say it did much. But the third one replaces dog with wolf, but doesn't have that G at the end. And if you notice the output, it replaced the first instance of dog, but not the last one here. So that's something to note. Next is awk. This is another command used for scripting. If you want to like filter for specific things in a CSV or something usually, or with something with columns, this is great for that. So this example or this line in the bottom left here, that is printing out the second argument, I believe, from this file. And then an example at the bottom, or it runs it on each line. I forgot to mention that. It runs it on each line. So in the example picture here, using print $1 and then $2, it's basically printing out the first and second words that are in each line. So this John manager, and then it just goes down for each of the lines, and that's great for scripting with specific.
I think that's for comma separated values.
Yeah, so in this example here, Nat mentioned it uses tag capital F, and that's specifying your delimiter. So what is your text content separated by? And that's how it knows what is your first, second, third, and so forth word. Is it by default a space? Space or colon? Yeah, usually you want to just specify this just to be safe. Otherwise, you might get something you don't expect. Another thing is grep. This is very common for searching for certain things in a file. So if you grep the word error in the example down here, it's able to highlight like where it finds it. But it also points out where, even if there aren't like spaces before and after the text, it'll highlight that as well. And now in the second command here, it uses tag W to specify this is the word and that it's looking for. So even though it has error in the word terror, it doesn't highlight that because you specified this is the word I want to look for, and it should have a space before and after it. But there's a lot of options to work with here. I think there's one to set like a regular expression. Something that you'll commonly do is like cat a file to display its contents and then pipe that into grep. And pipe basically means take all the output of a command and put this into this new command that I'm saying after. So moving strings around, similar to pipe, there's a couple other ones that are important to know as well. First is your standard input stream, and that's basically saying it takes the strings as input. So when you use the less than sign, it redirects your standard input. In this picture, we cat, and then you use the less than sign and then the file name, and that's basically inputting the file into cat. So it's basically the same thing as saying cat space example1.txt. This is just a fancy way of using the redirect. And then there's pipes, which I mentioned. It's not an L. This is a vertical bar. If you hold shift and press your backslash above the enter button, that's a vertical pipe. Yeah. And that pipes the output of a command and puts it into another one. So in this example here, it cats the file contents of this file here and then pipes that into sort. Sort is just a command to sort the contents by alphabetically. And then you have your standard output stream. This is the output for each command. It's kind of similar to pipe in some ways. In this example here, we have like echo hello from Texas. So it's echoing that output and saying put that into a file. So it's different because the pipes are piping into a command, and this greater than sign is putting it into the file rather than putting it into another command. So this is a little bit more advanced command line bash scripting. This is basically using bash in the command line to get like kind of what you want. Usually you have your scripts run by using // and then the name of your scripts, or using bash and then your script's name. Either one, pretty much does the same thing, but something to note is that your file has to be executable. We're going to talk about file permissions later, but if your file isn't executable, it'll give you an error. And also, there's also file permissions related to which user can like execute it. But yeah, I'm gonna go into that later. Here's an example of a bash command line example. So we have 4 line in. So basically for each line in whatever argument you have here, in this case, it's $cat poem. So this is saying execute this command and redirect the output of that command to this line. So it's gonna list the contents of poem, and then with this for loop is saying for each line in this file poem. That's what it means together. And then you have semicolon and then do echo the line. So it's basically saying print out each line. And then you say done when you want it to end. This example is kind of pointless because you just do cat poem and do this exact same thing. But I just wanted to show an example. So I have a kind of quiz for you guys. We're going to combine all the tools, and I want you guys to kind of figure out what exactly this does. I want you guys to try to figure it out first, but just by looking at it. And then after that, try each component of this command and see what that does, or try to think about it in that way. I think individually it won't work. Like if you just did grep tag E and then that, it won't do anything. So each component kind of does its own thing. But yeah, let's see if you guys can try to figure it out. And on Zoom, if you guys want to say what it does in the chat, you can go ahead too. Victor says, find all users with shell access into a file. Yes, that is correct. So what this is doing is first printing out etc password, and this is a file that contains all the users on the system. I know, we didn't give you guys time because that guy is too fast. But anyways, yeah, and then you're grepping using a regular expression. So it's finding all the lines that have or contain /bin/bash or sh. So this is saying users that have shell access. And then after that, you're using delimiters to get rid of everything else after the first colon in that file, and then printing out or only keeping the first field. So and then putting that output into this file called users. So actually, we can go ahead and try this. We'll show it. Yeah, I'm gonna stop share on here. Yeah. So normally, if we cat etc password, this will give you a long list of all of the like service accounts and regular users as well. A lot of these are end with no login, or I believe it's either disabled or like something like that. Yeah. Or false. Yeah, false. Here it is. Here's an example. But the main things to pay attention to are the ones at the bottom of the list, because these are ones that are created after your system initializes. So these, if you notice here, there's like 1000, 1001, 1002. That's your user ID. So all users that are created after file system is initialized will have an ID greater than or equal to 1000. So here, user, and then we have Adam and Anson. These are 3 total users, and each one has a user ID, and each of them ends with bin/bash. So that means you can log into each of these users and have a terminal available. But all these other users are either used for a service or just not available to users to log into. At the very top, as we mentioned before, the root user has a user ID of 0, and that's because this is the first thing that's kind of created. That one can be logged into, so that's important to note. Now, if we pull up, can you pull up the command? I can't memorize that. Yeah, so if I type that out, oh, made a typo. Real quick. Oh, yeah. So you can also use up arrow to repeat the previous command or show the previous command that you used, and then press enter to redo that. Yeah. Did I make any typos? Nitro type coming in clutch. Yeah. So this is the command.
Oh, I'm in the chat. Will you please, or Claudia asked, will you please explain the grep command option?
Oh my God, there's so many grep options. So this tag E here just basically says use extended regular expressions. And this is an example of extended regular expression here. So this dollar, if you're not familiar with regular expressions, I'd definitely try to look into that more in your free time. But to kind of go over what this does, we have this $sign means this is the end of the line. So everything before this has to be at the end of the line. And it's also evaluating these parentheses so that it's kind of saying like it's either going to be bash or sh. So that's what vertical bar is used for. It's specifying either or. And then, yeah, we just have the parentheses here. And then the colon is just like your Etsy password file is always going to have colon here. So these 3 lines will match, or it should at least. So again, this is going to output to a file called users. So if I run this command and then ls, we should see, yeah, we have a file called users. And if I cat that file, we'll see the users that we can log in as. And these are root, user, Adam, and Anson, as mentioned before. So thank you to Victor for mentioning that. And thank you for Claudia for the question. Yeah, we can share and reshare the presentation. Yeah, so these are pretty handy when you're trying to figure out certain things from certain files. In a competition, you might look for certain configurations inside of a config file. An example might be like if the root user can log in, and you can do that by checking your SSH config. So if the user can SSH to your machine, you would expect to see this option in the SSH config file called permit root login, and that specifies whether or not the root user can log in using SSH. Yeah, and now we're going to talk about file permissions. So as we saw earlier, there's this weird string of like a bunch of letters. R stands for read, W stands for write, and X stands for execute. And then there's 3 groups of these. The first group being your user, your current user. The group being whatever group that the user is in, and the other is basically everyone else. So, and like I mentioned before, this D in the front specifies that whatever is listed is a directory. And if it's just attack, that means that permission is not set. And this important thing to recognize here is that each kind of group of RWX can be represented with binary. So we have 3 digits of binary kind of. So the first one being 1, and then second being 2, and then the third being 4. And again, these are just 2 to the power of whatever spot they're in. So you can convert your file permissions into different versions. So like if you, oh, isn't this an exercise actually? I think so. Yeah. Homework. This is an exercise. So I want you guys to kind of like on your own try to figure out the octal versions and the RWX versions. Octal being this kind of binary, and then you have RWX is the version on the left. And just try to do either or because it's good to understand what's being set here. Let's just do all of them.
Right now?
We'll have them do all of them.
Right now?
Yeah.
Fine.
It should take like 2 minutes, hopefully. Again, the tag just means that that permission is not set. And remember, each I guess group has RWX in it, and then each of those has three binary digits that are set. So if there's the letter there, it means it is set. If there's a tag, it's not set. I mentioned, yeah. When I say tag, I mean the dash, as I mentioned before. That's true. That's true.
Detail your mentors.
When we say sentence, that's not the issue.
Well, obviously not. Yeah. Yeah. So some of these like phrases that we say really quickly, like tack. Another one is Etsy or ETC. I don't even know if these are like industry standard, like everyone uses that. That's just something that we kind of say to make things a little faster. Yeah, some people that are not like super experienced, you might just hear them say /etc, and you got to kind of understand like, oh, that's your config folder. But if you say Etsy, that's probably one of us. That's probably one of us saying that. Yeah. So I think a couple minutes went by. For the first top left one, someone shout out on the Zoom or in person what the octal version of that is. Yep. And then the top right one, convert to RWX. Yep, that's correct. And then bottom left, convert to octal. Yep. And then
I don't think they could hear.
that's true. Because the top left one was 744. Top right one was RW tac, R tac tac, R tac tac. And then the bottom left one was 521. And then the bottom right one, someone in the room? Yeah. RWX, RW tac, RW tac. Good. Wait, is it the other way? Oh, R tag X. Yeah. Now you're good, bro. So changing file permissions, that's where these octal forms and like RWX forms come in. You can change file permissions using chmod, and you can change the owner using chown or chown, yeah. So when you use chmod, you kind of specify the permissions that you want to use. So in this first example here on the right, chmod 777, and then your target file. So that's basically saying everyone can do everything to this file. That's definitely not very secure, but it is doable. Next, we have 775, and that is basically everyone can read, write, and execute besides everyone like not included the user and the group. So everyone else here in this W column cannot write to it, but they can read and execute. And then we have 755, it's pretty much the same thing, but the group and everyone else can't write. 664 is everyone or user and people in the same group can read and write, but everyone else can only read, and then so on. I definitely like using the binary format or octal format over the RWX one. There are different syntaxes for chmod using the RWX version. I don't know if we have it here, but we do. Yeah. So this first one is just using the octal format. The second one is an example of how you would use the RWX format. So it uses A and the plus sign to represent A is everyone, right?
Yeah.
Yeah, A is all. And then you're adding, using the plus sign, every permission for that group. So you're basically saying everyone else can read, write, and execute this file. And if we ls tech L to show the permissions again, we see that file, file 2 here, is everyone can do everything. And if we change the file permissions here, we can see this is 744. So everyone, or the current user can do everything, but everyone else can only read. And then this one here is saying group and others can read. So the A is for all, meaning everyone, user group and all others. And then G means group. I think U is user, and then O is others. So there's A, G, O, and U to know. That's why I don't really like using this format, because the numbers makes it a lot easier. But yeah, that's just an example. There's also something called immutability. So if you make a file immutable, basically what that means is it can't be changed or written to or anything. So basically it's kind of a way of protecting a file, but you would do that using the change attribute command or chatter, and then you would add the immutability characteristic here using +I and then target file. So you can also check the immutable bit using ls attribute or list attributes for that file, and then you can remove it using the minus instead of the plus. And something we haven't really touched on yet is using sudo, and this means super user do, or basically, isn't there also an S permission? Isn't that sticky? Thank you for bringing that up. S is another attribute called sticky. I can't remember off the top of my head what it does. I'm not sure.
I'm pretty sure it allows you to execute that file as root, like as an SUID.
What? Okay. Yeah, that makes sense. Yeah, I'm gonna hand you this mic so you can repeat that. You wanna throw it?
I believe SUID for or it's dangerous if the file is owned by root. If you were to execute something with SUID bit that's owned by root, then you would have root proofs.
Even if it's executed by just anyone with a higher permission than you. Oh, so set UID bit is obviously dangerous if root owns the account. But if really it's just if anyone if the set UID bit belongs to any account that has more permissions than you do, then you suddenly have more permissions if you can if either that command does something that can give you information, or if you can modify it or somehow extract information that you shouldn't have.
It's cool. Thanks for your guys' input. I'm not too familiar with that. But it's cool to see that we have some experienced users in the room. Yeah. So I hope that answers your question, Claudia. So yeah, we have the sudo command, and that just basically says run this command with higher permissions. Some commands require sudo and some can be run on its own. Like as we saw earlier, I can just do anything like list files, move files, copy, all that kind of stuff. But some commands like listing service status, I think does require it.
Yes.
Yeah, systemctl requires sudo. I think IP tables, which is a firewall, also requires it. And then we have SU and then the user. That just means switch user. So if you say SU roots, you're switching to that root user. And then if you SU tech, that's another way of saying switch to the root user. Yeah, and then we have sudo tech I. That's another way of getting to the root user. and sudo is kind of the same idea, I believe. I don't know. A little rusty. Okay, so sometimes it's different on different distros. That's good to know. Yeah. So now we can talk about how to add users. Like as we saw before, I added a couple of users in your guys' pods. So if you guys cat Etsy password now, you should see my name and Anson's name there as well. So when you add a user, there's two different ways to do it. One is add user. This is a wrapper for user add. It's definitely less clunky and prompts for password at the time. And user add is much less efficient because it doesn't create your home directories automatically, and you manually set password, I believe, after you create it, right? Yeah, I think Debian, different distros kind of handle it differently. It's interesting, but we consistently just use add user and recommend sticking with that one. I think for this one, is it tech M that specify? Yeah, if you use user add, and there is an option where you can say, oh, create the home directory for me. I think it's add or user add tech M. But yeah. And now we can go into managing users. Yeah, we have like different groups, kind of similar to groups in Active Directory, but that is another topic for another day. This is not group policy, but it does group users together. So you can do this by either using user mod or the ID command. I'm not familiar with how to do with ID command actually, but if you do user mod tac A and then capital G, you can add a user to a group by specifying the group after the option and then the name of the user, I believe. Yeah. And we talked about this before, user IDs and group IDs. So root user has a UID of 0. Services are usually UIDs of less than 1,000. And those are all the accounts that we saw after catting Etsy password. We saw all that kind of garbage before our users were listed. And then all your user IDs that are greater than 9,999, or not 9,000, 999, are users that were created by someone. Then we have password management. Like, how do you change the passwords for a user? So some would say password or or this first one here, but that is just short for password. So if you do password for and list a current user, it'll prompt you to change the password for that user. If you do password on its own, you change the password for the current user that you're logged in as. And then CH password is another way of changing password, but it's great for automation. So if you say like echo and then user2 : password, and then pipe that into the CH password command, that will change the password without much input after that. And this is kind of why we gave you guys the credentials in this format for the networking homework. We did like user : bruh. That's just because you're so used to like seeing CH password formatting like this. Alternatively, use the format above and finish with Control D. Do you guys know what that means? I did not write this. Yeah, these are a little old, but I guess someone could try that. I don't know. I'm pretty sure you could just press enter and then I don't know. It'll do the same thing, right? But yeah, so there's a lot of different distros and flavors of Linux that we encountered in CCDC. The categories for these are like Debian based and Rel based, and then there's just others that are very unique. So Debian based, the main difference between these distros are their package managers. And these are like the tools that they use to install commands, software, applications, and that kind of stuff. So Debian base, like Ubuntu and then Debian that you guys are using, use apt, apt. And then some of the common commands you would do is like update, upgrade, install, or purge or remove. And rel-based, like CentOS, would use yum or DNF, I believe, or DNF. Depends on the distro, of course. And then there's just a lot of other ones like What the heck is it? Suffering, APK, Pac-Man, Solaris. I've only heard of Pac-Man. I've never seen these other ones.
Yeah.
APK is using Alpine. Oh, that's good to know. Yeah.
That's just neat.
Suffering is Nix. Yeah. Nix OS. Yeah. So now I'm going to go a little bit into services. So running processes are often in the background, and they're managed by the system. The most common way to list the status of a service or enable or disable or start, stop, that kind of stuff is using systemctl. This is almost on all of the distros, and you just do like systemctl and then what you want to do to it, and then the name of the service. And then some of the older ones are service. This is usually working if systemctl doesn't, and then you have here's an example. It's like it's definitely simple. You can just do service and then the name of the service and then what you want to do to it. It's a little different in order from compared to systemctl. And then there's like RCD and initd, and these are uh systems, or these are for systems that don't have systemd. They're definitely annoying because you don't have very straightforward commands. Here's an example. You would start the SSH service, specify the location where the service is, and then just say start. Definitely not very user-friendly. Yeah, and here's some examples of using systemctl and service commands. For systemctl, once again, it's action and then service, but service is the opposite. It's service and then action. And then here's some of the examples. HTTP, SSH, Nginx are all services. And then some of the actions you can take are like status to see what the status of that service is. Start, enable, there's disable, stop, restart. I think that's it. Oh, mask. Yeah, mask. So masking is basically when you don't want the service to kind of be listed anymore, or you don't want to delete it, but like you don't want to use it anymore. That's a great way of kind of like throwing it away. Kind of a funny story in one of our competitions. I was fighting this red teamer. I disabled and masked file share service, and then a couple minutes later I checked again and it was unmasked and started again. I'm like, dude, turn this thing off. So I did it again, and then it was kind of like a back and forth, and it was kind of funny. But yeah, I'm gonna hand it over to Anson here because I do have to leave early. But yeah.
Oh, I thank you, Adam, for offsetting your responsibilities to me. That's fun. And then next, continuing off Adam, we have processes. Processes are programs running on your computers. If you put PS, the command on your computer, you see typically it lists all the processes for this terminal. Typically we use PS aux. It lists all the process instead of just specific ones, if I'm not mistaken. Yeah, we use PS aux a lot because our threat hunter Anthony, he uses this to see if there's any unknown processes running, and this is a great tip if you guys are trying to learn how to harden your Linux systems. Use PSOX, see if there's any outbound connections or inbound connections that are using a port and a process. Yeah, but yeah, typically red team have connection or somehow. Yeah, and then if you want to kill a process, you do kill tag9. Uh, you do kill tag9 and then the process ID, the PID. If you do PS aux, it lists the PID in one of the columns at the top. Bye-bye. Yeah. And then you have pgrep. Pgrep is to find the PID from a process name. You typically need to do this first before you do the kill command. And yeah, really pay attention to this because this does come up every time we have invitationals or even any type of competitions. If you're just wanting to threat hunt or blue team in general, learn these commands pretty quickly. Yeah, and then we have get some help. This slide obviously tells you how to get some help. There's also the man pages. If you do man and then the name of the command, it shows you what you could do with that command, what other options and arguments you could put into it, defining grep commands, help parameters, less or more. Less or more is used a lot for headless systems, which means like there's no GUI and it's only a command line. You would use this very often because you can't scroll. Like you can't use a mouse, you can't use anything. Everything's just keyboard. So it is important if you're learning headless, and that is my advice too. Even in containers, a lot of containers they use headless systems because they want those containers to be more lightweight and easier to use, I guess you could say. So they use less or more of these harder to tell. Heads obviously at the start of, is it the first 100 or first few? Yeah, we forgot the number, but head is definitely the top if you want to look at the top, and tail obviously as implied by its name, is the end of the command. And tmux, yeah, for Linux, we learned tmux very quickly because once again, headless servers come into play a lot into these competitions. So we use tmux commands to basically split up the screen because on headless servers, you only have one screen, but like if you use a laptop or anything else, you could, if someone at home were to use a Google Chrome browser, they want to have two tabs side by side. They just split one to the side and it splits into half and another half. But tmux does that for headless servers. So please take time to learn this. Yeah, for everything basically. But we use it for headless server. Yeah. And then here's the tmux cheat sheet. You'll go over this or
We're not gonna go over this because it's a whole lot, but yeah, basically you can just
take time to read it.
take a look at this.
Try it yourself.
The slides will be up today on the SciSec website, so you'll be able to see this there. Yeah, it'll be up early.
Yeah, I'll be up early. Thank you, Natalie, for that. She does a lot of work, sleeping away. And yeah, I'm not gonna go through this. Bunch of Linux shortcuts. I don't know why Adam put this here, but we do use this. It's very quick. At some point when you start using it, you don't really think about it. You just instinctively just do it. And I think a lot of things I do use are control left arrow key and control right arrow key. Just goes to the leftmost or rightmost word, or control A or E. Uh, yeah, control C. Yeah, cancel if you want to cancel something. A lot of processes are running. I wouldn't recommend canceling a lot of stuff they're running, but we use it if we know for sure like this command is not going to work out or this process in the background.
Yeah, so sometimes when we use Control C to cancel is like when we accidentally upgrade.
Upgrade our system, yeah.
Yeah.
I wouldn't
And
recommend updating.
yeah.
Yeah. Me and Nat, especially everyone in CCDC, we don't recommend updating or upgrading your system. Updates, yes. You should always update your system before running any app package manager to install anything. Keep your drivers or anything in the background that helps those commands updated. But upgrade takes like an overhaul of the entire system and updates forever. Funny story too. I think my first time using Kali Linux, I didn't know what to do, so I looked up on ChatGPT, how can I use Kali and how can I like learn to red team? And then the first thing they say is like, oh, you should upgrade your system. I upgraded that system. Like the whole 4 hours of that workshop is gone. Like I couldn't even touch the laptop anymore. It just blew up. Yeah, and then Linux security, very important. Adam and a little bit of me and Nat went over how to basically work around your Linux systems. But what happens after? Which is obviously, oops, the holy square of user management. You see this square-like structure. We have etc password, etc group, etc shadow, and etc sudoers. These are very important. They're usually the first things you check, or if you have nothing to do, just check now because a lot of red teamers, they like to create very obvious accounts. They don't really obfuscate, right, for this competition. So you clearly see like red team won or red team was here, anything like that if you are pwned. We start with etc password. Adam went over this before, but going over it, you start with your username, root, and then your password. It won't show your password in any scenario if you want to find out your password. Um, in plain text, yeah. So there is the shadow, which if you get the hash of it, but that's I think 2 slides after, but it doesn't really show it like how you would type it on a computer like a human would. Yeah, so if you do forget your password, either change it or get lucky. And then we have our UID. Users ID are important. Adam went over that. Root is 0. Anything below 1,000 are services. and anything above 1,000 are users, created users. Uh, this is the typical format, but we have encountered one red teamer we know personally. He's found a way around it. So, sometimes this is good base level knowledge, but very good people who are very good at their job could circumvent that. Then we have the group ID. As stated before, certain groups do certain things. They have certain permission, the comment, where the home directory is located, and the shell used. And the shell is important because the very first thing that when you log into is your shell. A GUI, obviously you see your home screen page, but for headless servers, you log in and you see your terminal instantly. And what happens when you have no shell? You can't you can't log in basically. Like it doesn't go to the terminal for headless specifically. I don't know about GUI because I mainly worked with headless servers. It changes you. And this is example of Etsy password. At home, Adam did earlier, but try cat space slash Etsy password. Shows all these things. You see the different users, the name of services, user IDs, and then the comment, and then the root users, and then the home directory where it's located at, and the shells after. And you see things like no logon. You can't log into these users. They're kind of like just services, if I'm not mistaken. Like you see man here, this man command, as I stated earlier. If you do man for a certain command, it shows you like a tutorial on how to use that command. And it's important to not really memorize, but understand a lot of this because like my first step for troubleshooting was when I first encountered this, I did not know what to do. So just take like a quick 5-second Google search to see what this is. And like, it's easier to have a clean VM and see what's not been like red teamed or been messed with. I really recommend that. You don't have to memorize it, but you have to get a general gist of understanding of uh, everything here. It does come back into play. Next slide. Then we have our group commands. We talked about the group earlier, but a lot of numbers, a lot of this semicolon stuff or colon stuff. We start off with the group username, then we have the password, stuff like before, the group ID, and then all the members of a group. The most important group, I would say, for beginners is just a pseudo group. You need to look at who's in the pseudo group because a lot of times in these competitions, they put random users as pseudo groups as vulnerabilities to make sure, hey, are you actually correctly blue teaming your own machine and have a good understanding of uh, is it least privilege, right? What's the whole name? I just know it's least privilege. Yeah, principle of least privilege. It's used everywhere, no matter what. I use that in even in my interviews.
Yeah, there's also the wheel group, which is pretty much the same thing as the suitors group.
Yeah, thank you, Nat. And then we have Etsy Shadow. This is a bit it's a lot because I learned this for NCAE, but the shadow grid basically hosts the password hash for different algorithms, and if red teamers get it, I don't know which tool they use, but they could reverse engineer your password and basically get into your system, which you don't want because that gives them initial access to just basically drop a beacon or NEC2. Obviously, on the screen, you see the username first, followed by the password hash. They use different algorithms. And then the third, number three would be last change time. Number four, what's the minimum days between each password change? And five, what's the maximum days? I forgot what six is, but do you remember what six is? Yeah, but this is just general gist of Shadow. And one important thing to note, I forgot to say, for Etsy password, anybody could cat it and read it. Uh, we talk about those pseudo root users and super users. It's important to know this distinction. You have group. I'm pretty sure you could read it, but you can't write it, and you can't execute it because those writable things is important. Because when we red team, like we tried for ITC last year, it's pretty hard when you don't have a lot of write or execute access. Because if you're trying to purvesc into a higher system, these typical basic Linux security skills kind of prevent you from it. And importantly, as I said earlier, Etsy Shadow, you can't even read, write, or execute it unless you're a root user or super user that has permission to do this. It's important because I said earlier, if a red teamer has the real password hash, that means all your passwords are just basically gone and initial access is compromised. And sudoers is a similar thing to that. /etc/sudoers, as I said before, and Adam, it shows, your environment path variables. If you see right here, this whole path, the secure path of what it references. And then you see here, user privilege specification. This root user can do all, admin all, and sudoers all. And there's uh, the directory at the bottom, etc sudoers.d. If you want to team dev or even just basically blue team your own stuff, this is a place to look for because we've encountered one competition where you see a bunch of users that are able to use sudo access even though they shouldn't. They're maybe like a web user like www data that's able to use it, and you're wondering, why does this user need to have sudo access when all it does is just log into this one specific website to see if it can be even accessed to? And once again, sudoers can't be opened or written by anyone. You need the sudo command, obviously, because you don't want to have random people to have access to who can use sudo. And what is PAM? PAM is important because it's kind of one of the first things you learn and the first things you check. It's an easy fix, but it's hard to learn because you don't know what it is at first, and we're teaching you now. PAM stands for a pluggable authentication module. It manages all your authentication. For Debian, we have common auth, and then for system or RHEL systems, it's system tech auth and password tech auth. I forgot the full command, but it's like slash. Do you remember that? The, the Debian one. I forgot the full absolute path for something, but it was like, is it Etsy?
I believe it's an Etsy Pam common auth.
Yeah. But it's a common file that you should get used to checking no matter what, because once again, deving and like blue teaming, uh, the first thing you want to look for is obviously, you want to harden your systems, but you don't only want to harden your systems, but the very first thing that protects you is just initial access, and authentication is initial access. You don't want to have unauthenticated users being accessing your systems. Yeah, and this is unfortunately it kind of hurts your eyes, but this is what common auth looks like for is this a headless system right now? I think this is the color. Looks like. Yeah, it might just be the file, but the very first line you should pay attention to because if this is changed to a one, the ignore, it means no matter what password you put on the first attempt, it accepts it no matter what. I forgot what the other things do, but this basically says PAM deny, PAM permit, and PAM cap. I'm pretty sure these are binaries that run in the background. More to talk on that, but Nat will help you with that. She's a good cow captain. Yeah, but this is a basic understanding of common auth and what it looks like. This is a basic, like untouched common auth file, so literally pay attention to this. We're telling you how to do Linux security.
I think this is also a situation that one of our red teamer friends has learned how to bypass.
Yeah. But that red teamer friend's like really like has years of industry experience, so like he does red team, but it's better to encounter these things right now because you learn very quick. And CCDC is an environment where you have to learn within a day or a week. It's just you just have to do it. If you really do enjoy blue teaming or administration, anything of that kind, IT work, you'll find some love in this competition. Yeah, I put that. And then cron jobs. These are my favorite because if you're debbing, cron jobs are the most basic thing ever. They're basically a scheduled task at regular intervals. There's the cron.d dot week month in those cron jobs tab. It could be good and bad. It's basically if you want to run something in intervals, but typically for anything deving or red team related, they want to have any running beacons or services they want to stop at a certain point. There's so much you could do because it's like bash scripting like before, how you want to code stuff definitely plays a lot into play of how they want to set up the cron job. And the easiest thing to do is cron tab tac E. It goes basically to whatever user's cron tab is running at the time. And there's also etc/cron D, which is the directory for cron jobs. And basically, easiest thing to do, if you have no use, kill it. You see running system or running service in the background that you know for sure. Just stop, disable it, and mask it. Or even if you're unsure of it, just comment it out in the cron job or in the cron tab because it's basically a file that you could edit. And this picture shows you like the syntax of it. Uh, there are different timings they want to do it, and there's also time zones you could put into the cron jobs.
All right, so now we're going to be talking about networking and firewalls, but the Linux version. Last week was more in depth. This week is just specifically Linux. All right, so first we have Network Manager and similar things. So these just manage any of your network connections. And you have Network Manager, which is for, I'm pretty sure like Debian and yeah. Then we have Systemd, Networkd, which is on Ubuntu, and I'm pretty sure I think it's on Arch as well. Network Manager, I think, is also on RHEL systems. Then you have NetPlan, which is kind of like a one-shot tool that helps you with configuring your network. And that is kind of like, it's not really a wrapper, but it uses Network Manager and Systemd, Networkd as a back end. This is very important to make sure that it's running, because it's giving you internet access.
And like building onto what Nat says, whenever you use any of those top three things, make sure not only do you change and save the file, but you have to apply the changes you do, because that's one hard lesson we learned.
Yeah, so you can do that by like restarting the system. For example, on depending on which distro you have, you can do like restart network manager or like restart networking, netplan apply. Yeah, again, it just really depends on which distro that you're using. Right, and now we're going to look into checking out your network connections. And you can use IPA, ifconfig, or ipconfig to get your NIC information. And NIC, again, stands for Network Interface Card. And this will just show you like what IP you have, what's your gateway, your netmask, all of that fun stuff. And something that's really cool, also really useful, is seeing what connections that you have with netstat or SS. Netstat isn't always installed on your system, which is really annoying, and you'll have to install it with NetTools, but it is what it is. So if you can see the screenshot, we're basically running SS tactile and netstat tactile, and they'll just show you different connections that are listening that your machine is listening to. And it'll show you like what protocol it's using, the current state, such as like listening or connected, not connected, as well as any ports that are associated with it and which process it's associated with as well. And this is very important for CCDC purposes because you can see like, oh, hey, look, somebody's connecting to me on this port and whatnot. So if you can see on both of them, they have ports 53 and 53, 22, and 8080, which means you've got a DNS connection, SSH connection, and whatever on 8080, probably a web app, but you can't tell for sure without looking at it or like going to it. Now we've got Nmap, which stands for Network Mapper. And this is really cool because it helps you identify which ports are open externally or like what people can access on your device from the outside.
WAN.
Yeah, from the WAN. Thank you, Anson. So this is really cool because it helps show what your attack surface is. So in this example, you're running Nmap on a device with an IP of 172.16.127.31, and it'll show that, oh, hey, look, you're able to hit ports 21, 22, and 80 on this machine. So that means people on the outside can make connections to your device using these ports. Yeah, this is also really helpful to see what potential services might be running on your machine in terms of the competition. And it can really help you think through what kind of firewall rules you might need to have. So speaking of firewalls, these are very useful because they are extremely useful and extremely important. Because again, the more ports that you have that are open, that means the larger your attack surface is. So there's many different ways that you can get hit, and that's not fun. And all of your firewalls should operate with an implicit deny principle, which means you're going to block everything, and you're only going to allow specific ports through, but those are going to be the exceptions. Yeah, and this should be able to work in the Western region, or I guess in CCDC overall, because I know they changed the rule so that you can't block outbound for workstations. All right, so we're going to be talking about IP tables, which is the tool that we use for Linux firewalls. Now, there are other things like UFW or NF tables, but those are kind of lame because they don't give us something that's more fine-tuned, whereas IP tables does. So IP tables kind of runs with this architecture where you have 3 different chains, and those chains contain different rule sets, or your ACL, as Adam was talking about it last week. And those rules will run in the priority of top down. So whatever is on top has the top priority, and the things below that have a lower priority, going in that order.
Output in order.
Oh, yeah. So the chains that we have are input, output, and forward. We're going to talk about that a little bit more later. But yeah, so then you have the default policy, which is if none of that traffic is the same as any of the rules that you made, it's going to follow the default policy. Yeah, so now looking at this, so we have the 3 chains, as stated before, input, output, and forward. You can, of course, make your own chains, but these are the 3 important ones that you really mostly use. Input pretty much is any traffic going into your machine. Output is any traffic going out of it. Forward chain is a little bit more interesting, or like a little silly to think about it. It's basically all traffic that goes through your machine, but isn't destined for your machine. So it's kind of like using your machine as a vessel in a way. Or if you think about it, it's kind of like, oh, I got this email. I think this other person needs it as well. So then you just forward that email to them. Yeah. Then we have the default policies, which are you can set by doing IP tables tac capital P, whatever chain you want, and then either drop or accept. Yeah, tac P stands for policy. And I'm pretty sure you do have to be, these are case sensitive. Yeah, and be careful when you're setting up the default policy, or more specifically, when you're setting it up, because there have been some times where I accidentally set an output drop and it kicks me out. Then I had to restart the VM. It's really not fun. So just be careful. At least make sure that you have stateful connections first, or your exceptions or your rules that you want. And to kind of delete your rules, you can do IP tables tag capital F, which is the same thing as flush. Then we have IP tables tag capital L to list rules. You can add, I think tag ln works, as well as tag line, tag numbers, which allows you to see what your rules are in numbered format. That's really, really nice, especially when you want to delete specific rules. You can also do tag n in addition to this, and what that means is you're not gonna do any DNS resolutions, so it's gonna be a lot faster, which is so much nicer when you're in something like CCDC where it's time-based and you're low-key stressing, high-key stressing.
Yeah, I think the hard lesson I learned is the IP tables flush rule. You basically never do this unless you have a complete understanding of everything. I think as beginners, I've used that because I was like, oh, why is my service not up? Let me flush all my rules. And after I flushed, I'm like, oh, it's still down. How do I bring that back? Because those rules are important because there's things like Docker and Kubernetes that kind of forward those rules. They do different ports. Yeah, they have their own chains and their own internal ports and external ports into your internal ports of your computer and external of your VM actually. So definitely be careful. Don't flush stuff without actually knowing. And um, if you do make the team, please remember this rule. It makes everyone's life way easier. And this does count as a big change. So if you do something like this, make sure to write it down and write down what time you do it at.
Yeah, and another thing to note is, at least for the Western region, for the past 2 years, they've been using an Alpine Linux VM as a router, so please do not flush that, or you're gonna be flushing all of the NAT scripts, or not scripts, the NAT rules. So then you're not gonna have a router anymore, or your router will not route, and that's not fun. Yeah, so here's an example of setting up IP tables firewall rules, and this is specifically for allowing HTTP access into your machine. So for example, you're hosting a web app of sorts, and somebody needs to make a connection to it, but only that person can make a connection to it. Or,
Okay.
well, I guess people can only make connections to that specific port. Yeah, thanks. So the first thing we want to do is allow all incoming traffic to port 80, because port 80 is HTTP. And to do this, you're going to run this rule. It's IP tables tag capital A, input tag P, TCP, tag D port 80, tag J, accept. And I know that's a lot of words, but let's break it down into the different parts. So first we have IP tables, which is the name of the command. Then we do tag A input. So what tag A does is it appends a rule to the bottom of your rule list, and you have to specify the chain. In this case, it's input because we want traffic to be allowed into our machine. Then we have tag P, TCP, which means you're going to specify the protocol. And because web uses TCP, we're going to specify that it's TCP traffic. Tag D port 80 means you're allowing it for the specific destination port, which is port 80. And it's important to note this is a destination port and not a source port because it's the traffic's destination. In this case, the source port would be a high ephemeral port. Then we have tag J accept, and tag J means jump. So it's like, oh, if the packets match these rules, what are we going to do? In this case, we're going to accept it instead of dropping these packets. And now that we have our allow web rule, we can deny all other traffic that's coming into the machine. And we can do that by setting up the default policy, because again, whatever traffic doesn't match your rule or your rules will go straight to that default policy. And we want to have a deny policy because we don't want anybody else to hit the other ports. And we can do this by saying IP tables tag capital P input drop. And again, the tag capital P is policy, so you're setting up the policy for specifically, in this case, the input chain. And you can have accept, drop, or reject for whatever you want to do with it. Accept allows these packets, drop will not allow these packets. Reject does the same thing as drop, except you're going to, on the other side, you're going to get a message saying, oh, your packets were dropped. Yeah. But we mostly just use drop because we don't really want to announce that, hey, you're being blocked. And now we're going to allow any connections, any outbound connections that relate to that incoming traffic. And we can do this by making it stateful. So making it stateful is important in this case because it allows you to have any like previous connections be able to hit port 80 or anything that's related, which means a logical packet in the network. So for example, if it's a new connection to 80, there's going to be a logical packet trying to go out to give the requester that data that they want. So this is also a lot of words. But the stateful firewall rule for this is IP tables, tag capital A output, tag P TCP, tag M contract, tag CT state, established related, tag J accept. And yeah, so what this does, again, tag A output, you're appending this to the bottom of the output chain. Tag P TCP, your protocol is TCP. Tag M contract means you're going to match the traffic to a like connection tracking or connection tracked packet. So that just means the connection of the packet is going to be tracked. And then tag CT state established related is the state of the packet. So in this case, it's established and related as denoted by that comma. And established, again, is just any traffic that's already been there. And related, again, is just logical traffic. Because like if you have incoming traffic, you need outgoing traffic. And yeah, tag J accept means you're just accepting all of that traffic. So you're allowing it to go outside. And then after that, because you don't want any other traffic to leave, you will be denying all of that by setting up your default policy. And you can do this by saying IP tables, tag capital P, output drop.
Yeah, I want to mention what Nat said earlier. It's in a specific order for a reason. If you do it like out input drop first, and then you put allow incoming 80, you won't receive any connection because it looks at what's at the top first. So definitely do pay attention to the way she does put rules because uh, firewall is very tricky. You do have to have a very good understanding of what you're doing. Otherwise, machines just won't receive traffic.
Yeah. And usually I just do the stateful things at the very top so I don't have to move it or like append rules in a specific place. Hey, that's it.
No, there's a secret lab, guys. Aren't you excited? Who's excited for a secret lab? Yeah. Is there a sign-in sheet? No, unfortunately, for summer, there's no sign-in sheet because, we're doing boot camps just so we could teach and it's more tradition. I do recommend coming in person because you do get actual help from us. So the people in person, yeah, if we're able to, but most likely we will, or at least help you get there.
If you're able to come in person, we recommend coming in person. We know there are a lot of situations where you're not able to be here.
Yeah, but other than that, please come in person. It does give you advantage over your other people that don't come in because you do get personalized help. We we want to get to the people in person. We'll help you online, Zoom too. Well, that's just you, Nat. You're just lonely. Okay, I'm not lonely. But yeah, please come in person. Fall though. Fall is mandatory if you do want to make CCDC. The requirements are you need to attend both semesters of CPP and also that you need to attend every week of boot camps, if I'm not mistaken. Yeah, every week in person. Yeah, no Zoom. We do that on purpose because we do want to get to know you. A lot of CCDC's team bonding, right? Because this team bonding does go a long way. It does go into the workforce, and it also helps you with just networking and being a human being in general. That's the easiest way to say it. Yeah, but yeah, and we have homework. Aren't you guys happy for homework? Due August 8th at 5 a.m. Please go to this website. We'll leave it up a bit, right? So people can do it. We'll leave it for like a minute or two. And we also put it in the chat, which Nat is doing right now. And this is what the people in person get. You know, they get a benefit of us helping them with homework and how we would do it. Do come in person if you can. Nah, Timothy, I feel like you really like homework. We're gonna pay attention to you now on your homework and really grade it. You're welcome. Now we're joking though, but that's a funny comment. And this is our homework. Nat will probably go over it right now.
All right, so this is going to be building off of the pods that were set up for Networking Week. It's very important to do Networking Week homework before you do any other homework, just so that you have the right WAN IP address on your router, and so that you have static IP set up on your Linux and Windows VMs. It's fine if they have the DHCP like automatically set IPs, but having a static IP is just nicer and easier because it doesn't change.
Teaches you more about it also teaches you more about just setting up networking. Everyone on the team needs to know networking, some shape or form. Obviously, Nat is more experienced because she has more experience. But you do need to know networking. It's like it's a non-negotiable. That's why she said you're gonna like it no matter what.
And yes, you do like it. Yeah, so this is Linux week. At the top, we have the initial setup, the VPN stuff, navigating to Camino, whatever. And so we have questions at the beginning to just answer in the document. It's pretty straightforward. Please don't use AI to generate your answers. We know what it looks like. You're not gonna get feedback if that happens.
It's not hard.
And yeah, this homework isn't hard. It's also been addressed in the slides. And now for the lab, this is the more hands-on portion. We're going to be using the pods that you've got set up. So you're going to set up a website with Apache, then set up a database. And as a bonus, you can set up the website so that it displays whatever you made in your database. And what we would like to see are the answers to the questions above and documentation on how you completed the tasks. I guess talking more about homework and what we want to see as people grading it, please be kind of concise, but also explain what you're doing. If you're going to say, oh, I do this, please show that and maybe say why you're going to do it and things like that. And please make it look pretty too. It makes our lives a lot easier. So we don't have to go through like a bunch of text. But yeah, and your networking homework has been graded. You have comments on it. Yeah, for the most part, or I think they're all pretty great. And oh, that's crazy. Yeah, so thanks everybody for being here. If you have any questions, feel free to ask
Now,
now.
Discord.
Yeah.
Or in person.
Yeah, if you're in person,
You do get a leg up from
you can ask us. If you guys have any questions, you can put it in the chat or unmute yourself. Otherwise, we're available on Discord most of the time. Oh, somebody says, how come the homework are worth 0 points? Because for the summer, we're only doing the homework to kind of like help you in a way. It's for your own benefit and it's not towards team consideration. But once we get into the fall boot camp, these homework will be worth points and they will count towards your you being on the team.
And to add on to that, you might be wondering, oh, well, I'm attending summer. What's the point of even doing these homeworks if fall only matters? It actually does matter because a lot of these competitions, you need weeks and weeks upon weeks of experience. And to just even doing boot camps, it gives you a leg up because uh, you're starting out the year and boot camps happen during quizzes or classes and they take up a lot of your time. But if you do these boot camps, you're already ahead of everyone. It gives you kind of a space, and also using that space, you can either relax if you feel more comfortable in securing your spot on the team, or give you more time to go in depth into hardening your systems or understanding Windows and Linux and networking too. So we do recommend you to do homework. It's almost mandatory in a sense, in my eyes. It is mandatory, but it does help you because we also give good feedback and how
It is debatable.
good. Okay, I'm not sure about Adam, but me and Nat definitely good give good feedback, and uh, definitely does help you into landing a spot on the team and overall just better homework. Yeah, and make sure you do documentation in a sense that if anybody were to read it, they could execute those same exact commands and replicate it. Any more questions? Damn, no one in the room likes us. I see.
You just got a thumbs up confirmation that everybody loves it.
Yeah, it's fine.
I was just gonna ask, what distros should we be looking into?
Yeah, I'll answer that. The answer is good luck. We can't give you hints because it is how the competitions ran. So we want to give you like a simulated environment for tryouts. Uh, Modest advice, just look at the slides and look at the distros that we used.
Low key, all of them. Um, I think a lot of the common ones we've seen are Debian, Ubuntu. We're not talking about Windows. Alpine. We've seen Nix.
That's like awesome.
Yeah. Sometimes CentOS.
There's always a Debian of some kind, so do interpret that. It's usually the easiest OS to learn, but yeah, but it doesn't teach you as much as other Linux systems, in my opinion. If you do want to get good at Linux, do headless servers. Practice all those things we talked about, those Vim commands, those tmucks. It really does help you in the competition because once again, you want to have those little advantages over your competitors, and they ultimately build up over time because that first hour you do competition really dictates how the rest of the competition goes. Any other questions? Question? Alrighty. If there's no other question, uh, please ask us in Zoom. Mainly Nat, she's free most of the time now. She's done with her internship. She has a lot of. Oh wait, she got 1 week. It doesn't matter. It doesn't matter. Please bother her or Adam. They will be very helpful. I'm starting my internship soon, and I'm gonna be dying. But if there's no other questions, thank you for attending. Hope to see you next week.